Hi everyone and welcome to day 32 of 100 Days of Code in IoT Challenge. Today we're going to explore the subject of unit testing in embedded environment. We're going to do it with ESP8266, PlatformIO and Visual Studio Code. And my plan is to try two different testing frameworks, where the first one, that is a default on PlatformIO, is called Unity Test Framework, which is a C unit testing meant for embedded code, like low-level stuff mainly. And the second, for more abstract code, is called GoogleTest, very popular testing framework in C++ world. So let's get started. Okay, let's start from creating new project. So PlatformIO quick access open and the new project here. I've got a name for my framework. However, as I said yesterday, this is still going to be published as a library, not as a framework like with Arduino, because that's going to be much more work and it's something that I will do in the future. So for now, we're going to keep it as a library. And to create a library with PlatformIO, you just create a PlatformIO project. I've got the name, which is Uni1. That's how I'm going to call my library, my framework, IoT framework, right? We're gonna start from Node MCU 1.0. That's our ESP8266. And the framework Arduino, because that's gonna be the base. Even if I turn this into a framework at some point in the future, Arduino is still gonna be the base of Uni1. Okay, and the default location for the location. So finish. And we should have our project created in a few seconds. There we go. There we go. Cool. So yeah, because this is just a library, I am going to remove a lib directory since we're not gonna be using any private libraries. This whole thing is going to be library, right? In terms of PlatformIO.ini configuration, there is one thing that we're gonna need for testing on embedded environment, and that is monitor speed, which is the default one for ESP8266. I actually need to experiment with higher values because it might be possible to put a higher value so we could increase the speed of deployment. But anyway, let's stick to what we used to do and what we usually do, right? Cool. Right. So as for the testing, what I'm going to start with is to look into a README inside the test directory. And here we can find the link to documentation on platformio.org. And I've got this already opened here. And here we can find all the informations about unit testing on PlatformIO. They have a very nice example, the demo application. So if you click and go ahead to local and embedded calculator, this is what is going to open. So it's a project on GitHub, an example calculator, and all the tests, like all the configuration, can be found here on platformio.ini. Right, you can see there is a native and Node MCU. I'm gonna tell you in a second what native is. And SRC, which is the actual library. I think it's not this one actually, because what they do, they use a different they use a different directory structure. So they have just a private library calculator instead of we're gonna do it in the other way. Cool, calculator and CVP and H, right? But yeah, like in this example, what we're gonna need first is to have a production code, right? Something that we would like to test. I mean, not if you do test-driven development, but we're not gonna do test-driven development today. I'm gonna do test-driven development for the developing the futures. So that's gonna be in the future, right? Tomorrow. Today, I will focus on testing the code after implementation. So for that, this is quite important. I'm going to rename essentially the main.cpp and remove those two functions because this is meant to be library, right? So there's no main.cpp, it's just the library files. And I'm gonna actually copy paste all the files from the core library here in a second, but let me start with an example. So example.cpp, and we will have two functions here. So one function is going to be sort of independent function that can be tested on a native environment. And let's just call it add. So that's just gonna add 2 ints. The simplest example, right? It's actually not void. It's gonna return int as well. The simplest you could do, right? Let me rename this to HPP. So we don't need to define any headers. Cool, so that's one function. And the second function is gonna use ESP8266 native functions, right? So for that, let's maybe do something like, let me think about this. Set built-in diode. And that's gonna take the state. And what we're gonna do is just digital write on the built-in LED, and the state is gonna be what we pass, right? I could make it an enum, but you know, just for the sake of simplicity, right? So if you pass high in here or 1, or like actually any value except 0, this is gonna write to the built-in LED, and just, you know, if it's 1, I think that's also high state. So that's gonna be switched off. It's for the built-in LED on ESP8266 is actually contrary, right? So low state is diode switched on, and high state is switched off, as far as I remember. But yeah, we're gonna be able to test it with the unit test, right? So that's our example that we have. And now let me explain what is the actual native environment, right? Because that can be a little bit misleading, right? So for that, let me go to the example and copy paste what we've got in there. So yeah, native environment. And for the Node MCU, we need to ignore test desktop. Because this is what really a native environment is. It is a desktop. So that's a specific environment on PlatformIO that allows you to run the code on your machine, right? On your local machine, on this computer. So you don't need to deploy it beforehand to ESP8266. And that can be used for any sort of code that doesn't use ESP8266 native, like microcontroller native functions. And this is the case for the add function here, right? This doesn't use anything from Arduino. Okay, but if it does, if it uses something, it is not really, and it's not really possible to make the test. I mean, like, you know, I can imagine an example where you could take the native ESP8266 native functionalities out of the equation, right? Out of extract it out of some class or function, then pass as an argument only. So that could allow you to use mocking, right? But I'm gonna show you this in a minute how this is done. But yeah, essentially the point here is if a function or class doesn't use native Arduino functions, something that needs to run on the board, then you can use the native environment, which means like native on this computer, right? And if it uses ESP8266 native functions, so like, you know, Arduino framework functions, and it needs embedded environment, then you're gonna have to use the actual environment for the particular board, and in our case it's Node MCU V2. Okay, and that's why this configuration here with the test ignore entry, that means for the Node MCU V2 it is going to ignore folder test desktop, And this is the one we're gonna start with, right? So for that environment, all the tests inside this directory are not gonna run, right? And yeah, so let me show you how example test looks like. Also, like we're gonna still look into calculator, the example from PlatformIO, and for test desktop test calculator, I'm mainly interested in the include. Right. So as I mentioned at the beginning of the video, the Unity is the framework that is used as a default one. Let me just close those and open the test desktop. Let's just have something like test example. It's a default framework that is used with PlatformIO. Unity test framework, right? It is a bit confusing with the Unity for the game development, right? And from here, I need a main. This is how you initialize everything. And I'm gonna pick a random function. I will rename it in a second. So this is still sort of like, you know, test. I'm gonna do test add. We can have test adds two values, right? That's what we can do. And I'm gonna have to put this as an argument to run test macro, right? This one for now I'm going to remove. Cool. You know what? Maybe instead of test example, let's call it test add. It's gonna be better. Cool. So yeah, so essentially that's how you initialize the Unity test framework. You need a main function. This runs right natively again on my computer, so there are no setup and loop functions, right? It's just main function. This is how you would write a C or C++ code on the desktop. Okay. So yeah, so main and Unity begin, Unity end, and in between run test on each test that you have in here. At the moment, this test is empty. But yeah, what we really want to test? What is the subject of the test? So the subject is really, we test if add adds two values. Okay. So we need to have those two values and then set some sort of assertion on that, right? But before I do that, I need to include our example HPP, so we have access to the code from here. And now here I could do something like that, right? Add 1 and 3, something like that, right? And then have an assertion here to check if the sum of 1 and 3 is 4, right? But for that, let me for a few seconds go to official documentation of Unity test framework, because this might come useful. Okay, so what is Unity? This is a very low level, just pure C testing library. As you can see, it follows ANSI standards, and it's portable, expressive, quick, simple, and extensible. You can actually use you can do mocks as well here with CMock, that I'm going to show you in a second when we think about using mocks. And here is just on a single page, it shows how to use that framework, which is pretty straightforward because like it's just few macros you can use. It all starts with the test assert, the basic macro where you are supposed to pass comparison. Okay, the only problem with this one though is that it doesn't show you explicitly why the code failed. I mean, it just shows you that, you know, those two values that you compared were not equal. That's it, right? So what you could do is to add a message. That's one option, right? Or even better, use different macros for comparison of different data types, right? So if you compare int, then if there was an error and they were not equal, you're gonna get more detailed error message, right? So as here, it says expected 2 and was 1, right? For the hex 8, it shows you in the hexadecimal format, and also that works for strings. and arrays. And I think this is it. There's not many of those macros. In Visual Studio Code, let me go back to it. In Visual Studio Code, actually, you are able to use the code completion to check what macros are available. So you see the asset is the base one right here, but there is many more, right? We have char double. I think it's for most of the standard C types. Okay, we even have something like less or equal, greater than for all the basic C types, right? Data types. Cool. Smaller than, and so on, right? So yeah, this library is pretty straightforward. If you have a small code base, for example, and it's mainly C, I would recommend that library. Let me just do this one. So because we know we operate on int, we're gonna do test asset equal int32, and the expected value in our case is 4, and actual is this one, right? So we can write our test. Even better, we could do something like that, and then have expected actual, right? So that's how we write the test. Cool. And to run the tests, again, super simple, super simple. You just open the terminal, right, using this button in here, and you can use either PlatformIO test or even shorter PIO test. And that's gonna build everything for you and run the tests. There is one issue here, and that issue is due to the fact that we include Arduino. Yeah, let me just fix that quickly. Because on the native environment, there is no Arduino.h header. And what we could do is either separate that into two different files, which I'm thinking actually about doing, because that's shorter solution, right? So I'm gonna put the add into add here, so there is no headers included. And then for the set built-in diode, because we actually need Arduino.h, we're gonna keep it like that, and maybe I rename example to set built-in diode. Okay. So it is quite important, because yeah, if you include Arduino.h, it's not gonna work with the native. Right, so now we just got that, and this needs to be add.hpp, and let me run the test. Okay, and that passed, right? That passed. It works. This is how the output looks like, right? So it shows us what tests has been, what test the test runner went through, right? With the line, which is actually this just shows us the line with the run test. So that's the line 12. Okay, so 1 test, 0 failures, 0 ignored, and success. Okay, so now I'm gonna break this test on purpose. So let me try to change that, maybe maybe here 1 and 5. 1 plus 3 plus 5. So that should obviously fail. And let's see what the output is going to be. Cool. Yeah, okay. So we got something. And that shows, as you see, test add CPP line 7, which is here. Expected 9 was 4, right? So we expected that it's 9, but it was 4. But this is obviously incorrect. Now this is correct. One additional thing. This is actually better. I try to break it here. So we add 1 to everything and try again. Okay, so that's what we got, right? So now it's the other way around. So we expected 4, but we got 5 because of the issue here. So let me remove that. And I'm gonna run it again. And there we go, right? So that works. So yeah, this is how you run tests on a native environment on your computer for the code that doesn't use ESP8266 Arduino specific code. Okay. So yeah, that's for the desktop. One additional thing I would like to mention, which I think is important, and that is an issue with having multiple files here. So if you have multiple files in the desktop for the Unity test framework, you cannot have multiple mains like that because the code is not gonna build. It's not gonna be built. There is an issue with that, and I think they are explaining how to fix that. But yeah, there is this. Please note that you will need to use unit test guard if to hide non-test related source code. For example, own main or set up loop functions. There is something mentioned about that. But to be honest, I did a quick test and I couldn't get it to work. Even with this approach with the guards. If you have multiple files here and multiple mains, you get an error. Also, if you try to put this main into a separate file, like a bootstrap, and then have those tests separately, this is also not working. I guess you would have to put them into SRC, which doesn't really look nice because tests, in my opinion, shouldn't be like, I mean, maybe for someone that could make sense, right? Because in a JavaScript world, we have a spec files, they usually sit next to SRC. So maybe that could be one option. You know, maybe we could give it a go quickly. So what if I do something like, let's try it. So I move this file here, just quickly to try to solve this issue. So I move this file here and I'm gonna call it add test instead. Okay, that's what we got. And the main is going to be moved to something like a bootstrap. Bootstrap.cpp. And that's what we do. We just put the main in here. And then what we're gonna need to do is to include, we just need to include Unity. We actually don't even need Unity, to be honest, but yeah, let's do it. And the test, right? So that would be add, that needs to be HPP now. So add test HPP. And now that should actually work. So if I run this, yeah, that works. Okay. Okay. So yeah, this is apparently the way to do it. So you just keep a bootstrap.cpp in the desktop, in the test desktop folder inside the tests. And then you just use the sort of like JavaScript spec approach, right? Where you keep the test files next to the actual files. So, you know, it's not too bad. However, I see one disadvantage of this approach, and that is on the bootstrap.cpp. The problem here is you need to add all the run test macros for all tests, right? So imagine you have like 10 files, all of these 10 files have like 10 tests, and you need to put the run test macro for all of them. So this is the moment. This is something that is not very convenient with Unity test framework. However, if there is a way and you know about it, let me know in the comments, because there might be a way to avoid this sort of situation where you need to put run test for all of the tests. I don't know, maybe based on prefix or something else. Anyway, that's how you can do test with the multiple files. So I'm pretty sure that allows me to, you know, that would allow me to add more of the files here. And you know what, I'm gonna speed it up and just try just to double check. I'm gonna speed up and try with the division or multiplication. Maybe I try with multiplication. So speeding up now. Okay, done. And I'm going to run the test now. Okay, that works. Let me break it on purpose. So we're gonna do something like that. And let's see if the test fails. And that failed. Okay, and that failed because 10 was 20, which is not correct. Cool. So yeah, essentially this is how you do it. This is how you can have multiple files and even, you know, your test sitting next to the actual implementation, which is not too bad, but still for you know, adding all of those tests in the bootstrap.cpp, that could be a little bit problematic. Maybe there is a workaround with a macro. You could build some sort of macro, but yeah, I just leave it to you and let me know in the comments. Cool. So that works nice. That works nicely. And let's move to the Node MCU v2 environment now, right? So how to test in embedded environment. What if you need to test a piece of functionality that uses internal ESP8266 functions, okay? And this can be done with embedded testing, for which I need to create another directory, test embedded. And inside test embedded, we're going to create set built-in diode test CPP. Okay, for now I'm just gonna keep the test here, and maybe I move it to SRC and just follow the same approach, right? We had with the test desktop. But for now, let's just focus on the test only. Okay, and for this test, for this particular one, we actually need arduino.h. We're gonna need a setup function and loop function, even though we're not really using it. Probably loop function is not really required. Okay, but anyway, let's have a look how this is done with PlatformIO example. So let's go to test embedded, test calculator, how they have done it. So they still use Unity, and okay, and this is the setup file. Okay, this is very similar. We don't really need a loop function. Okay, so let's do it. Something like that. They say it's 2 seconds delay, but to be honest, just 1 second is enough. We're just gonna have a single test in here. And also something that is missing would be the serial monitor to be set to the same value we set the monitor speed to. Okay, and now we're gonna need to have something like a test that I'm going to call test set built-in diode switches, maybe changes to high if high value is passed. Something like that, right? This is gonna be pretty straightforward. It doesn't actually add any functionality to an existing built-in. Hang on. Actually, what we could do, changes to high if that's set built, maybe sets built-in diode voltage to high. Okay, that's a bit long, but it's at least, you know, it's expressive. That's how the test should be expressing what the test actually does, right? So we test if set built-in diode sets built-in diode voltage too high if high value has been passed. I had to do it longer. Great. And let me define this test here now. So void this one takes void. And inside, what we really want to do is to call our set built-in diode, but we need to include it first. So set built-in diode, set built-in diode, and the state is going to be high. And now to test it, this is just going to be a simple asset. We don't have Unity here, which is required. Not this one. This one. Test asset equal. Yeah, and expected is high, and the actual is actually gonna be digital read, because this is more like integration testing, right? On the ESP8266. So we checking if the state has changed, right? And that's gonna happen on the built-in LED. So that's what we're gonna do. Digital read is on that, okay? So that's what we do. This one is already set. Cool. I think that's it. Let me open the set built-in diode HPP as well to make sure. Cool, yeah, okay. And right, so now the next step is to make sure your ESP8266 is connected via USB to your computer, because that needs to upload the code. Okay, I've got this connected. And the next step is just running the tests. We just need to run the tests, and this is gonna run the native ones on my computer, and after that, the embedded ones. Right. Yeah, there is just some warning at the beginning. And yeah, it takes a while because it needs to upload the code to ESP8266, so that's taking a while. There we go. Okay, so that ran the tests, and what we got is passed, right? So that was successful. Nice. The embedded tested passed, right? But we can add another one to check if we set it to low, it's actually gonna result in low. Okay, so I'm gonna copy this, paste, but change if we set it to low, if low value has been passed. So that's what we're gonna do, right? So we're gonna check on low now. Okay, and we have to use the run test macro and pass it to that macro. And let me run them again. Oh, I see the warning is about, oh, okay, now we got failed. We expected 0, but we got 1, okay? And this is why the tests are useful, okay? I know what the issue is. This is why I prepared this particular example, and let me fix that, okay? So what's wrong? What do you think is wrong? I can tell you what's wrong. To do digital write on built-in LED, you need to set the pin mode to output first on the built-in LED. That should fix the issue. So this is why the tests are useful. Yeah, it is complaining. I checked the warning messages. It is complaining about the wrong constant I used. The built-in LED is deprecated, so we can change it later to something else. Okay, now it passed, right? So that resolved the issue. Again, as you can see, this is why the tests are actually important. And now, following the approach from the test desktop, what I could actually do is to just move this to SRC, change the extension to HPP, right? And here create a bootstrap.cpp and copy this code to here. And also, I think Unity would be required. And actually Arduino as well, just to be safe. And we need to include the actual test, right? So that will be set built-in diode test. So now this has access to those. Okay, yeah, and I think this is how this is done. Okay, yeah, let me just quickly make sure this works. Okay, passed, yeah. So that's how you can have multiple test files, regardless whether it's for the desktop or embedded environment. However, I would suggest to indicate it somehow, right? At the moment, this can be a little bit confusing because like they all have a test suffix. So ideally you would have something, maybe for the embedded, you would have test embedded or integration or something like that, right? So that would be different suffix than just test. But I leave it up to developer, up to you if you are interested in this subject to do it yourself. And yeah, and the last thing about this Unity test framework that I would like to talk about just quickly, I'm not really gonna show you any examples, is on the CMock library that is recommended. It is recommended here. I think pull in CMock for full mocking support. Okay, so if you need a simple mocks, so mocks is essentially you need a function that you can control the behavior of, right? That is sort of fake function, right? This is mock. I mean, you know, there are many definitions because you can also distinguish mocks and stubs, where usually on the mocks you set some sort of expectations, but I'm not really gonna go into this discussion right now. So we're just gonna think of mock as like any test double. That's the actual name for all of them. Okay, and the point of the mocks in CMock library is actually it is a bit. I would say it's interesting approach. Not sure if it's ideal. Maybe that's the only one if you really code in pure C. And that works with the headers, right? So you need a header file. And for that header file, that framework, that CMock library generates a code, an implementation that is the actual mock, okay? So that's what happens. Let me just show you how this is done in this example. Okay, so we have does something as defined here, a function. This is just a header. Does something that takes A and B. Here we can set the behavior of this does something, what it does, right? And what it does is it expects to receive 1 and 2 as an arguments for A and B, and that's gonna return 3. We make it return 3, okay? So we stub it to return 3, something like that. For 4 and 5, we're gonna return 6, but we also expect 4 and 5 to be given to this does something, right? So we expect does something to be called first with 1 and 2, and that's gonna return 3. Then it expects does something function to be called with 4 and 5, and that's gonna return 6. And then it expects the does something to receive 7 and 8, and it's going to throw an error, status error ops. And then we actually have what is under the test here, and under the test we have a function called calls does something. So we expect that this function inside calls does something 3 times, right? First time with 1 and 2, second time with 4 and 5, and third time with 7 and 8. So that's essentially how this works. It uses Ruby underneath as a language to generate the code, I suppose, to generate all the codes for your mocks. So that's like, you know, it relies on the code generation. But yeah, you know, the point of this CMock with Unity is really the simplicity, and there is even C++ support. But I see it as more meant for a very low level C code It doesn't mean it couldn't be used with higher level code, right? It does have C++ support as well. But honestly, my subjective opinion, I'm not really sure about this code generating thing. And also with the, this is sort of forces developer to go with the approach where you need to specify separate header files, right? So you have H files and C files. This is the approach that actually forces me to do. So my HPP approach where I have everything just in a single file, that unfortunately wouldn't work, right? But anyway, this is just a tool, and I'm pretty sure that there are definitely cases where that would be the best tool to be used. Okay, so that is for the Unity, and that's how you do all of this. Probably all of these files require also something like pragma once, so we make sure this is just included once. Okay, this is actually gonna be included once, but yeah, just to be safe, we could do that as well. And we're gonna do one last run, and that's gonna be the code that is going to my repository, so you can download it, play around yourself, maybe build on top of it. Cool, yeah, the test passed. Right, having this all done, I'm gonna switch to GoogleTest. Right, for GoogleTest, what I would like to add is that I'm planning to use GoogleTest as a default framework for my IoT framework. The reason simply is GoogleTest is working better with C++, right? So Unity, as I showed you, is really nice. I kind of like it for a very simple code, or I think, like, you know, in C code that would be the best solution. But for C++, where I would like to have mocks on the classes quite a lot, and also we use callbacks, I think GoogleTest is going to be the better solution. But let's prove it. However, I'm afraid for today this is it, because I think the video is already too long and I don't really wanna end up with 2-hour video again. So I'm gonna end now, and we continue tomorrow on GoogleTest only, right? We're gonna start clean, and I will do GoogleTest. I'm gonna start with a simple example like this one, and then we're gonna move to the actual IoT library with all the tools, right? So out of the core library, we're gonna try to test maybe even dispatcher, okay? Right, if you want to stay up to date with my channel, don't forget to subscribe, right? So as soon as I upload the next video tomorrow, you will get notification. Thanks for watching, and see ya.